Welcome. In this lecture, I want to talk about subtraction and division within rings. Are these something we can do? Okay. So do rings have, so here's the first question is, do rings have subtraction? Because we've talked about addition and multiplication, but can we subtract? And the answer to this is going to be yes. So the answer is yes. Okay. We just add the additive inverse, right? Just add the additive inverse. Right? So, you've done this kind of thing before where you add, like minus something, and that's the kind of the same thing as subtracting. So let's kind of look as if I had, so if I wanted to take, so how would I work, what does it look like to say 3 minus 5? Okay, well, that's the same thing as saying 3 plus minus 5. Right. So you don't, usually write something like that. In a ring, you'd write something like this because then you're actually using what you know that you have. Okay. So then what the question is, what about division? Okay. So that's kind of question 1. And then question 2 is a little bit harder. So question 2. So do rings have division? And the answer, I was trying to do it as like, if its answer is yes and it's green, like go, you can do that. So the answer here is sometimes. So we'll do it like yellow because it's cautiously orange. Okay. So we need kind of a new definition. Okay. So we're going to suppose R is a ring. Okay. Then by definition, okay, then we're going to say that an element A in R. So this is the first thing, right, to focus your brain in on is what kind of thing am I talking about. So an element A in R is going to be called a unit. So is a unit. I'm going to do this in green because that's when that becomes yes. So we'll keep with our color scheme. So is a unit. Okay. If and only if, right? So this is kind of, I write that in definition. So first off, we check what kind of object is it. A unit is an element of a ring. Okay. Not any one, but it satisfies, it's the elements of a ring that satisfy certain properties are called units. Okay. So what do they need to satisfy? Okay, so it's going to be that there exists a B in R. So a B in R. So that we have that A times B equals our multiplicative identity equals B times A, i.e. our element A that we want to be a unit has a multiplicative inverse in R. So has a multiplicative inverse in R. Okay. So something to kind of focus in on here. Well, first let's focus in on boxing our definition. So this is the definition of a unit. Okay, and after doing that, then we're going to focus in on a few little details in here. One of which is, notice that we have a there exists thing. So in order to be a unit, you only need one multiplicative inverse, right? You usually only have one multiplicative inverse, okay? So we only need one. This is an existence definition, okay? Great. So now we can get back to our what we were talking about over here. So now here's kind of when can we? Okay. So we can only divide by a. So can only divide by this element a. Right? If I'm in a ring, I can only divide by a when a is a unit. Right? Like, it satisfies this property over here. So it has a multiplicative inverse, and we're going to use that multiplicative inverse. Okay? So then what we get is, so then in this circumstance, we're going to have that C divided by A. So if I had this another element C, and I want to divide by A, right? Well, how do I actually write that? So that is actually, so this is C times A inverse. I'm going to do this in orange. Okay. Why am I going to do that in orange? Because it's actually, this is, you know, this is going to be our notation for our multiplicative inverse. Okay. So maybe I'll even highlight that, that this will be our this is the notation for the multiplicative inverse. Multiplicative inverse. Okay, great. So, subtraction and division. So subtraction is always going to exist. And you just do, so how do you subtract? You add the additive inverse, okay? Which is kind of, but this might have been, if I'd started out with like minus 22, this would have turned into 22, right? Sometimes, but it's the additive inverse that you're adding, okay? And then for the division, so when can you divide? And the answer is sometimes, and it's precisely in this circumstance where you actually have a multiplicative inverse, which is something that you can multiply by your original element so that you can get out the multiplicative identity. Okay, so I hope that made some sense and was helpful, and I will see you in the next lecture.